Happy Software Sundays, builders. In this space, we have real conversations about technology and the impact that it has inside of your community. And we help you shape what we can do with it next. So, if this is your first time joining us, thank you for being here. Welcome. And if you've been rocking with us for a minute, it is great to have you back. Keep coming. You're in the right place. Uh, Before we get started, I do want to acknowledge the passing of Reverend Jesse Jackson. And I just wanted to highlight that I heard his name before and I knew like very vaguely kind of the work that he's done. But after hearing about the current situation and his passing, I ended up looking more into what he has done in his legacy and found out that he had ran for president back in the 80s and was one of the most successful candidates, African American candidates, uh, at his time before Barack Obama actually won the election. He also worked under Dr. King to run Operation Breadbasket, which was their economic project to get more African Americans hired and getting good paying jobs. And he spent a significant part of his life, a majority of his life, advocating for peace and cooperation, and not just in the US, but also globally. And his legacy cannot be minimized, even if, some people like myself may not have known everything about him. But he's definitely someone worth looking into, and his passing is uh, definitely a loss for the community. And again, just look into him, look into the work that he's done because it's worth knowing. Uh, I also want to highlight that it is March 1st, so we are in the Women's History Month. So think about that. Think about the women in your life that have had an impact on you and your development. Not just your mother, but your teachers and the people that you work with every day, and how their impact is on just the world in general. And have some respect for them. Greet a woman with love and thank the women that are important to you. Because I know we all have those people. And speaking of women that I am very grateful for, it is also my wife and I's first anniversary in a few days, March 5th. I actually know the date. Uh, but we've been married for 1 year. We have known each other for about 17 months, and I am very grateful for the year that we have had. It has been a very interesting year. It has been challenging at times, but I am still grateful to be in a partnership and experiencing life with such an amazing and beautiful one. So, happy anniversary to my wife and myself, and I wish us many, many more. So, we could get started. Quick disclaimer: Software Sundays is for informational purposes only and is not professional advice. The views expressed in this show are my own and those of the people quoted, and may or may not reflect the thoughts of Build, Learn, Impact or their affiliates. If you are looking for advice based on the topics discussed that may or may not apply to your specific case, please consult your own legal, business, professional, or tax advisor for that advice before making any decisions based upon information you find in this show. So with that being said, we got the liability out the way. Let's get started. We got a lot of interesting things that happened this week in tech and in the market. First, Jack Dorsey lays off 40% of Block. saying that AI has changed the game and that intelligence tools have shifted the way you can build and run a company. This was a very interesting story and development for me. I mentioned last week how different executives are finding that AI, or there is a disconnect between executives saying what AI can do and employees' feelings about what AI is actually doing. Today, we are seeing that, and throughout the week recently, we are seeing that from a leadership perspective, these companies and their leaders are feeling that AI is ready to do much of the work that they kind of hired employees to do. That means there is less of a need for as many employees or as many people on their team. Something that I am taking away from it is a little bit behind the scenes. And to me, it doesn't actually signal that AI is better at all types of work compared to humans. But it is very clear that with AI, a human could now do the work of 10 other people. So a lot of these companies had experienced a significant hiring growth and significant increases inside of their teams between the pandemic and today. Some think Block actually tripled in size over the last 3 to 4 years. And so now that increase in hiring, that over hiring at the time, coupled with the fact that we have AI tools which now make it less likely for you to need as many people without a corresponding amount of work being available, is leading to the layoffs that we're seeing. We're seeing it become common understanding that, hey, there's not enough work or that for 100 people. There might be enough work for 10 to 20, but one person can do the work of 10 people. So there's no reason for me to still have 100 people. So they are looking to be more efficient with how they're spending money. Again, the major driving factor that I'm seeing also is the fact that investors are starting to prioritize and value different things today. They are valuing efficiency over employment, valuing margin expansion over labor growth, and especially AI leverage over organizational scope or scale. There's no longer a need to have a giant ship that is doing the same numbers as my little uh, yacht. You gotta have a little small yacht, the baby yachts, right? The starter yacht, versus those super ships. You might get a warship or the cruise ships. You're starting to see that people want to be more efficient with what they have. They want the people on the teams to actually start utilizing the tools available so that we can work faster, work more efficiently, and do more with less. And so we're seeing that in the labor market. We're seeing that it's becoming a sign of like success to start laying people off. And of course, from a labor's perspective, from an employee's perspective, that is challenging to deal with. It always sucks to know that your your job is no longer needed at the company that you have dedicated time, right? So that is part of the equation, but from a organizational standpoint, these are actually becoming good, right? The stock market is rewarding companies that are making moves like this. Block's stock share or price for their shares rose about 20% after the news broke. So there's definitely some leveling that has to be done from an incentive perspective, as well as from uh, a goal or objective perspective. I don't think everyone's incentives are aligned right now for what we believe AI can do and for what we want it to do between labor and companies. So it's something to keep an eye out for. We will actually see if the workforce reduction that has been done at Block and all of these other companies actually results in a dramatic increase in revenue or profit margin. That is to be uh, seen. Like every company has not had that type of result, even if the stock price is reflecting people expecting those benefits to materialize. So it's something worth keeping in mind and keeping an eye out for as we continue in 2026 and over the next 3 years. Some other AI news. OpenAI CEO Sam Altman has defended the resource consumption of AI and its demands to run and train artificial intelligence. One of the major cries right now in society, in the market, is the amount of energy that AI is has demanded since it has become more mainstream. From a training perspective and from a running perspective, all of these workloads that run AI require very physically large data centers. They require large machines. Those machines require a lot of space as well as cooling to keep those machines functioning properly. Those data centers are starting to and continuing to grow in scope, in footprint, and in their need and their demand for energy generation. In 2023, the global, well, this is one of the stats that was mentioned in the article that I found, was that in 2023, the global data center energy consumption was equal to the total amount of energy used and consumed inside of a Germany or France. Now, I thought that was an interesting comparison to make because it seemed very sensational. It, if you listen to those numbers, it seems like data centers are powering so much energy that they are rivaling a country. But what I have kind of gotten from it is that 100% of the data centers in the world that are used for more than just AI, they are used for banking, they're used for healthcare, they're used for different uh, services and infrastructure that we really do need and really do rely on. 100% of those data center resources and the energy demand is equal to less than 1% of the total amount of energy consumed by the entire human population and globe, right? Germany or France is one of almost 200 countries. So if you think about, you know, comparing, it doesn't seem like it's comparing apples to apples. It seems like the comparison is overstated, and it has been overstated by a number of different media outlets and people. But one concern that is very important to highlight is the fact that the energy that is consumed by data centers and by most countries is dirty energy. We are still heavy into fossil fuels. We are still not transitioned to net zero. There has not been enough of a shift made inside of how and where we're getting the energy to meet some of those carbon goals that were placed 10 years ago or even earlier in this decade. there was a goal to be net zero or carbon net zero by 2030, or it could be 2030. I have to backtrack that, or even 2050. But at the rate we're going today, we are seeing an increase in energy demand without seeing uh, that same shift and transition to the clean energy sources. So the actual net result is worse than if we had been kind of using the same amount of energy before AI. So today there is a acceleration and a call for people to and companies to shift to nuclear energy, solar energy, and wind energy. But that build out for that infrastructure, it takes years to actually uh, finish. It's going to take years for those farms to be online. It's going to take years for regulation and developments in nuclear to actually meet the demand and generation standards that we need in the US, but also globally. And although some of that investment has started, right, we do see companies and countries moving to creating offshore wind farms. We do see a in greater investment in tax credits and in from a residential or commercial standpoint inside of building and buying batteries and solar panels so that we can have a cleaner form of energy. And we are seeing companies moving very quickly to innovate inside of nuclear energy and small modular reactors so that we can start generating more gigawatts of clean energy. But the challenge is today we're not there, but we are seeing increased energy demand from AI. So I can see that the fear is real there from an energy perspective because we aren't where we want to be. And because AI has taken so much investment and it's taking so much, like it's so hyped up today that we're starting to see so much of the capital available. Instead of going to clean energy projects and programs, that money is going to funding and fueling the AI build out. We're building more data centers knowing that we're going to have to connect them to increasingly less efficient energy grids. So it's something that hopefully at some point we can see the ROI for AI actually start to benefit clean energy. But the fear is that it'll take too much time to see that ROI. And in the meantime, we are doing our climate and our planet a very large disservice. So it's definitely something worth looking into. One of the things that I have mentioned before and found out is that some data centers, specifically in Germany, there's a Google data center that has been configured so that the heat output generated by those machines is being used to warm and heat homes in the area. So that could benefit the energy consumption without because at that point you're not duplicating the amount of energy being used, right? 1 watt is being used not only to power AI or power the cloud, it's also being used to warm a family's home. So that could be something that helps from a trust aspect and from a climate aspect to make sure we're being more efficient with every watt that is generated, no matter where that watt is coming from. But it is far from becoming the norm. It is far from becoming a great thing for us to be using more energy. Because again, AI has not really done as much as CEOs say it's changing the way work is being done. That's true, but as much as people are saying that it is going to create this utopia reality where AI can just do everything for you and it just makes everyone's life easier. we have not gotten 100% of the way there. So in the meantime, we have to just be mindful of what we are trading to get to that phase. And it also is interesting the fact that uh, Mr. Altman mentioned that like he's comparing the amount of energy being used to train AI versus the amount of energy being used to train a human. I believe that that was a little bit insensitive for the people that are very anxious about AI and technology replacing them. Um, it's almost like you're saying at some point, what at some point, once the AI is more efficient, we really won't need the human. And the people are scared of that. They're scared of hearing that type of uh, story. They already feel it, they fear it, they're anxious about it. So it doesn't help from that perspective. But I believe that he is getting to a truth that is very much worth knowing and understanding. Today, or even if you look throughout history, there were and there are jobs today that are being done by computers that were traditionally being handled by humans. Much of the computing that we have today, or even like the compute that you have in your phone today, was being ran by computers, which was an actual job title back in the 20th century. There were people that could do math like a computer. Uh, there were people that washed clothes. There were people that you know uh, did things that computers can today do much more easily with less amounts of energy, and that makes those functions one more easily to spread, more easy to spread, and it makes it so that more people can get things done. It really just does make us more efficient. It's like saying that with a washing machine, your grandmother could be more efficient at washing clothes than she was when she had to do it manually herself. That is true. But if that person doesn't get a job or doesn't have something to kind of shift their energy and attention to after they are no longer needed in that role or that function, that becomes a societal issue that is not being addressed when we just say, yes, AI can be more efficient, and when it does, we're gonna not need you anymore. So definitely something to keep in mind and think about from a societal perspective. But yes, technology is always going to have that impact inside of the economy and how we do things. Today, getting from point A to point B with a car is 1,000 times more efficient than having that same route with your legs, right? So that doesn't mean that the person that could have carried you 100 years ago from your house to your doctor's appointment or wherever it may be is less important. It just means that we can do something more efficient with that energy that's being spent. Let's, instead of making them carry you, let's have them train to be a doctor. Let's have them train to you know generate cleaner energy, whatever it may be, like whatever their passion is and whatever the need is for society. Let's kind of shift people there. Again, the risk is that the shift doesn't happen as quickly as the displacement. If we no longer need the role, but we haven't created the curriculum and the pipelines to train people into these new jobs, then that entire like everything over that gap is a dangerous place to be, especially if you don't have the ability or the access to get the resources that you need. So it's a very important thing to consider and think about. But some of it I really do believe is sensationalism, really. And then some other news, just Palantir Technologies officially moved their global headquarters from Denver to Miami in February. So, if you're familiar with Palantir, they are a data analytics company. They do a lot of work in the enterprise space with governments and hospitals and those types of companies with using the data that they have available to create uh, to create workloads that are driven by the data that they have. So they do things with AI, they do things with big data and analysis of the data, of that proprietary data to create better outcomes for these different industries in the government and healthcare and even financial. They have decided and joined a number of other companies that have shifted their headquarters from other areas of the US to Florida. Florida and Miami specifically is interesting because in the previous administration, uh, Miami, along with 30 other regions in the US, have been designated as tech hubs, meaning that these areas have been identified as places that can curate and grow uh, high skilled workforces, as well as having the resources available to become a place for those resources to, again, grow in their skills, but also have the talent pool available to innovate and generate more innovation in those spaces. So that, along with the fact that Florida has become more of a corporation friendly state, right? They don't have a state personal tax, or they don't have an income tax, and they have adjusted regulations to just make it more beneficial for companies to, move their teams there. It's becoming a place where tech is becoming the driving factor of the economy. It's becoming a place where talent is going to start to, and it is already uh, doing, is starting to uh, cluster there. You're going to start seeing changes in the amount of education available, the housing market over there. You're going to start seeing changes due to the fact that it's becoming more attractive for high net worth individuals and people in tech. So it's a great opportunity for Miami and the people that own over there. Again, real estate businesses and those things. And it be hopefully that opportunity shifts to the people that have traditionally lived there, where they have access to more capital if venture capital firms decide to move there. If companies decide to move there, they have more access to better and high paying jobs. So that's the goal. Uh, I am definitely going to keep that in mind as a place to kind of keep an eye on to see what's happening there in terms of the tech space, what events, what organizations are uh, you know, calling for people to join them, those types of things. But this is a shift in how and where skills are being found. Today or traditionally, you might see uh, fintech in New York. You might see uh, high tech edge technologies inside of Silicon Valley. But when we start seeing companies like Tesla and uh, Oracle moving their headquarters to places outside of Silicon Valley, like Austin, Texas, that gives an opportunity to help distribute, again, some of the opportunities available, because that's what we need inside of the US. We need more people having access to the roles. We need more people available to train all of the amazing talent and the amazing minds that are there in these different cities outside of just, LA. Silicon Valley isn't in LA, but outside of California specifically. And I'm thinking about it from a, idealistic perspective. Honestly, a lot of these shifts have been driven by, tax benefits for those corporations or even a regulatory, uh, preference, right? They are choosing to deal with the governments and the political groups that kind of align more with how they want to do business. And yes, that is true. Yes, that could cause some long-term issues over time, but I'm going to choose to see it as an opportunity for those areas and those regions to kind of experience more growth. Whenever I think about Florida, I hear people talk about Florida as like the craziest place, or you find the craziest people inside of Florida. Maybe with a little more education, a little more opportunity, you may not see that, but that may not be a thing, right? You might start having people with some sense coming out of Florida. And I'm not coming for the Floridian. I'm just saying these are things that I heard, things that people told me. So I'm hoping that the opportunity grows over there, and we can jump into our questions for today. Uh, Before I do that, please follow, follow, like, subscribe, comment. Let me know what your thoughts are. Let me know where I missed the mark. What do you disagree with? And if you have any questions, always put those in the chat, and I would love to discuss them with you.
What should a PRD include?
So a PRD, a product requirement document, is the contract that eliminates ambiguity and align stakeholders inside of your organization. It is the document that will tell you the definition of done for the specific product or feature that you are building. When we think of a PRD, it is definitely more of a product focused document. It does not need to have any specific implementation details from a technology perspective. In the PRD, you really would want to focus on asking the questions about who are we building this for? Why is it necessary? When do we need it by? And what are some of those functional and non functional requirements for what it has to bring and deliver from a user standpoint? Uh, I think it's important to highlight as a software engineer that the PRD is going to help you drive the technical documentation and engineering of the solution, but it is not something that requires a heavy technical mindset, especially in the early uh, creation of that document. The PRD is going to be very useful and built right after the idea. The idea is going to help, clarify the space that you're building in and what you want to build. And it will be a living document that changes over time as different perspectives come in, as customer discovery continues, and engineers take a look at the document and look at and determine feasibility. The PRD and the information inside of it will change. So you would have a good experience with these documents if you put them somewhere where they can live and grow organically and have more than just an engineer being able to access it. Uh, if you think about a PRD from a product perspective, or if you think about the product, Uber is not a product that you can build a PRD for, but you can build a PRD for their rider app. You can build the PRD for the dispatch matching engine, or you can build a PRD for their payment service. There are specific aspects of the platform or the ecosystem that can be, specifically designed and built for. If you try to build a PRD for everything that Uber does, you're going to create a document that is not very useful for any type of engineering to come after it. So think about it as a tool that can help drive different areas of the business from pricing to customer experience to engineering. As an engineer, once you have a PRD that has been created, your goal is to help refine it, help identify any gaps that exist inside of that PRD. What is the thing that is not being mentioned that is worth mentioning when and before you start building or touching any type of code? And it's important to clarify that yourself if you're going to be building the product, but it's also important to have an understanding that the PRD is going to represent the guardrails that your system has to align with. So you want to be informed about its development and understand the perspectives that have gone into creating and refining it over time. It should be something that you interrogate at every stage of the development process. You want to make sure that you are aligning the technical architecture documents with the PRD requirements. You want to make sure that any type of diagrams that you create understand the system and the context that is being created by that PRD. And so it is a document that is closer like to high level company benefits, but as an engineer, it's very important for us to understand how the business is looking at the solution that they want us to build, because that is what we have to build for. A lot of the times, engineers that don't have the clarity that a PRD or a good PRD can provide, they will start to build things that are maybe technically accurate and robust, but may not have def- uh, a quantifiable business purpose, and so become useless to the company as a whole.
What is the difference between an API and an SDK?
So an API is going to give external developers access to the resources and data that you and your team are owning and making available. That API and that data could literally be anything, uh, but it is the contract that you are creating with your users to say that if you give me this, I will give you this. Right? It is, if you want this, you must give me this. It is a contract that just makes it easier for the external developers using and consuming your API to get started with and get value out of the data or the systems that you are providing access to. And that external company or that external developer or team can be a different team inside of your organization, or it can be an external organization completely that really just relies on the intelligence that your business is providing. An SDK is more of an abstraction layer on top of the API that is specifically geared to making it easier for external users to consume and use the API. It is a opinionated way to access the API that really just abstracts away everything but give me this and I give you this. It makes it easier for a developer to say, I want to use your API for creating a new tool without having to understand that I need to add these specific headers or add this format to the data that I'm sending so it can work inside of your system. It is a way again to abstract that contract so that I don't need to care about any changes inside of the contract. I just know, give me this and I'll give you this. It's a way to make the experience better. And it's just in a different layer of abstraction. If you think about an API as the back office system inside of a restaurant, the API is the implementation details. Again, it's how do I fulfill a order? How do I process a payment from a customer? How do I schedule a reservation in advance? The system that is being used to uh, schedule, right, to record the person's name or the guest's name or their phone number or the time that they selected, that can change. The restaurant cares about that, but the customer doesn't care about that. The recipe that you use to, create the meal, whether you use 3 shakes of salt versus, 5 shakes of salt, that is an implementation detail that lives inside of the API. And the customer doesn't care. They just want the meal that they want. The front office side is the SDK, which is the hostess that is, just taking the request from the customer over the phone, however they do it, like whether over the phone or in person. Um, or the waiter that is, you know, listening to the order and then going back into the kitchen to actually make sure it gets fulfilled according to the requirements and the request given to it to them by the customer. That's more of your SDK layer. And I really want to highlight the fact that the SDK can be any type of client. And it's really just a mental model to abstract the fact that you may not be in charge or own the underlying data and processing being done. That abstraction can be in person, sitting at a table inside of the restaurant. But that abstraction can also be you ordering from a app like DoorDash or Uber Eats, where you're just saying, I want this. And a lot of the heavy lifting is done without you having to do too much. You just make your request, provide the payment, and some magic happens behind the scenes. As a client, you don't care about what magic is happening. You just want to make sure that you can validate that and trust that the request that you put in is going to have a deterministic response. So every time I say I want this, it comes out this same way. So that is your responsibility as an API developer to make sure that you are clearly communicating the requirements that you need and being consistent about what you are delivering. Otherwise, your customers will not be satisfied. And that's what you do not want. Some of the most popular SDKs or APIs that are winning in the market today are Stripe, which makes payments accessible to developers very easily, and even Twilio, which operates a communication as a service product that allows you to build any number of apps on top of it. And a very popular one that I don't know if everyone thinks about as an API provider, although they are literally the largest or one of the largest API providers, is AWS. They have turned all of their services into a API. First, internally, where everything from infrastructure to a service like S3 can be accessed and used through an API. It makes the managing of those resources just so much easier for the clients, however they are accessing the tool. Their SDK is available in a number of different languages: Python, Golang, JavaScript. They have SDKs in many popular languages. But that client could also be the AWS console, right? Because an SDK is just a client. The console is just another client. The CLI is another client that uses these APIs in the background. And so think about your SDK and that client as a very opinionated way of using whatever the tool is. And if you build a useful API that allows your customers to build on top of it, whatever their specific business needs might be, that allows you to shift from just providing a product to providing a platform that is infrastructure for another business, right? There are thousands of companies that rely on the platform created by AWS's APIs. There are thousands of companies that rely on the infrastructure, the API that is provided by Stripe to make sure that they can handle payments every day reliably. So that is the shift that can come between thinking about an API versus an SDK and whether you want to deliver a product or a platform to the market.
What does poor performance look like as a software engineer?
So most engineers think that poor performance is about writing bad code, or poor performance is about, or I'll say performance is about writing the code, or even about, staying up to date on the latest technologies or frameworks. But in reality, engineering is more about solving the problems that you are given and solving them in a way that is reliable and scalable as the business grows and as the problem set changes and develops. So if you are a poor engineer, it's usually about your behavior or mindset, not so much about the technical skills that you may or may not have. To start, poor technical execution is obvious. It's very simple to see and clear to see if you do not understand the fundamentals of engineering or even programming. Uh, it's very easy to see that you ship code that doesn't work. It's very easy and simple to see that you don't understand data, whether it's the data type, whether it's creating a variable, or even understanding the fundamentals of networking and control logic. That's something very simple that we can all see from a technical execution perspective. And honestly, I would say most people, if you are at all interested in becoming an engineer, that is the thing that most people focus on. And that is more difficult to be bad at because it's really like any skill you can learn over time, but it's something that people kind of overemphasize very early inside of their career, especially in university where you want to just learn all of the languages, or when you want to learn all of the new technologies, Kubernetes and things like that. But it's not very common if you actually have a interest inside of software engineering to be poor technically. Most engineers are going to have a challenge and fall short on their mindset and their ability to work autonomously. And that means being proactive and being able to take responsibility for different areas that they may not be, explicitly assigned. A poor engineer is going to look at a problem or look at something that is happening near to them inside of the organization and decide that it is not their responsibility. They're going to decide that I am not the one who was assigned this task, or I'm not the one that needs to care about this problem. From even if you think about from a customer's perspective, they're going to say, I don't care about what the customer wants. I care that I was assigned this ticket to uh, create this API or whatever it may be. They're not going to be able to think about the fact that the ticket that they were assigned is directly created to benefit the customer. So they're going to create an artificial boundary and barrier between what they can deliver and what they should deliver. That is something that a great engineer should not do. You need to make sure that you are understanding that technology and engineering is a team sport. You need to be able to pull different people across your organization, pull them together, and make something happen, whether you were blocked or not. Another challenge is the fact that when a poor engineer gets blocked, they decide to just stay blocked and they may quit. They may give up. But a great engineer is going to make sure that they are not missing deadlines. And if they are missing deadlines, they are communicating that to their stakeholder. They are making sure that even if the velocity is moderate, that they are still consistently delivering results, or at least making it clear that work is being done to unblock them or to move things forward. A software engineer can write really good code and still be a poor software engineer in terms of performance because we're not hired to just write code. And the ability to write code has been kind of solved by AI. AI can write code. Now it is going to be very important for engineers to do things that AI cannot do. You have to impress your team and impress your stakeholders with more than just code and more than just knowing a framework. You have to be able to put these different tools together and look at the problem that you're solving for to actually, meet those needs, not just the technical need that was kind of defined or given to you inside of your Jira ticket. A poor performing software engineer is going to have an inability to think bigger. They're going to not be unable to see past their nose. They're going to get into a performance review and take some type of feedback and not take it well. They're not going to learn from the feedback that's being provided. They're going to freeze up. They're going to go into a business conversation and see that, oh, hey, we're not talking about something that I'm interested in. So I'm going to check out. I don't need to care about the business and what the business is doing because I'm not interested in the business. I'm interested in code and delivering the technical details that I actually care about. All of that is related to poor performance as a software engineer. So you want to avoid that as much as possible and understand the expectations of the system that you are operating in.
How does the SDLC change with AI automation?
So the software development lifecycle is shifting today. With AI, there are aspects of the phases and process that you can do much faster and much more easily than you could a decade ago. If you think about the SDLC process as researching and planning and refining, building, reviewing, and testing, and then running, deploying, and documenting what has been built, you can see that there are some aspects of that shift dramatically with AI. With AI, research can be done so much faster. We can use tools like Notebook LLM to go very deep into researching the tools that could solve this specific problem that I was given. We can kind of sort through all of the options for this specific problem that needs to be solved. Whereas in the past, you would need to manually go through Stack Overflow. You would need to manually go through the docs for those tools to see how do these compare based on the context that I had. That means designing a solution becomes much easier because now you can have a partner, an agent working beside you to help filter some of the things that aren't going to be really helpful for you. And it can make that job easier. It makes the reading of the docs much easier, or at least finding the answer that you're looking for much easier because now you can have AI search through all of the docs, find the area that is important to you, and highlight that to you so that you can actually go in now and focus on the area that is actually related to the problem that you are solving. So this makes reviewing much easier than what you could do previously. Uh, Planning becomes so much easier because now you have a partner that can go through the planning session with you. They can highlight anything that you are missing inside of your plan. They can, uh, you know, critically review the plan that you have in place and asynchronously or synchronously make sure that any gaps are being uncovered, any ambiguity is being clarified, and it even ask questions that you may not have asked yourself if it was just you looking at the document. And it makes it easier to collaborate because you can get a lot of the work done on your own time without having to sync up with another member of your team, which makes collaboration and work just so much easier because now you have two people, two minds, two entities going in and refining a document, and then they can pass this off very easily to another member of their team, which can who can also be augmented with AI to help refine, ask questions, and do more than what they could have done asynchronously uh, traditionally. Diagrams for architecture become so much more easy to develop when you use tools like Napkin or even ChatGPT to build a diagram based on the architecture or the design that you are describing. So that visualization of what we are building becomes easier. It helps the team to understand from a different perspective what is in place and what we are trying to get to. And so that can help make ideas more clear and make your job as an engineer much easier. On the surface level, everyone is understanding and aware that AI can help you write code. It can help you develop products faster. And that is true. AI can be used to create an MVP. And I say MVP, I use that word very loosely. It can help you create something that you can look at that can help you refine the design or the architecture that you really want to build inside of the real MVP. But in terms of AI, it can help build more advanced wireframe. I think that would be the more accurate description, which makes development easier because now we have a product, a design that is not just wireframes that you can point to and move around the screen that way. You can actually have a wireframe, quote unquote, that you can click and actually see different things change and happen inside of the product. So as a UI developer or a engineer that is building the tool, you can more easily say, oh, this is what I need to do to actually achieve these results. It makes your testing process much easier because you know the outcome that you are looking for. It can make refactoring code inside of your code base much easier because now if you have to make a very small change to something that is well defined inside of your code base, those corresponding changes in other functions in other areas of the code can be done by AI without having to require you to go in and make those changes yourself, which makes the development process faster and easier for you as an engineer. something that AI can help with to an extent is code reviews, but it is still very important for engineers to make sure that there is a human in the loop for the review process for the code. We have to make sure that the lines of code that is generated by AI is actually being reviewed and fact checked and refined by a human. AI is going to hallucinate. It is going to add things that you do not need. It is going to go in directions that may not align with the actual objectives of the business or the technical design that you have in place. You have to be aware during the review process to catch those mistakes when they happen. And in a similar thread, you have to be aware during testing that you need to really smoke test the thing that is being built. AI can build some things that look like they are working, but they may not work exactly the way, again, you expected them to work. You have to have a human being in place to step in, test it out, try to break what is in place, and then refine in that product or that code or that system from there. So think about AI as getting you closer to production, but again, we need to have that human quality gate between development or QA and production because we want to make sure the thing that we put in front of our users, the thing that we are stamping our name of and our approval on, is actually something that we can trust and something that our customers can trust because an AI hallucination during development can result in a delay inside of releasing a feature. But an AI hallucination inside of production can severely damage the trust that your customers have for your system and your team as a whole. But there are a number of ways that AI can help just make things better. Even from a documentation standpoint, if you have an AI agent that is reviewing the testing with you, you can do things like automate the testing of something that you clearly define. And the AI agent can actually click around, enter some input, and automate that process for you. But they can also even document from a user perspective how do I actually use this product and put that documentation inside of a format that you can actually put in front of customers more easily without having the engineers spend too much time documenting how the system should work. You just make the job of transitioning from development to operational or production just so much easier for you and your team. So think about the development of AI as not something that makes the SDLC process disappear, but as a tool that shifts responsibility to areas that builders are more useful for and more useful and necessary to complete.
Which software engineering skills are future proof?
So if you want to be future proof as a developer, you have to and you should think about what are these skills that have remained important over the past. Today and in history, data modeling has always been important. Understanding security and the infrastructure that you are building on top of has been important. Understanding how to make trade offs between latency and throughput, time and space, and even extensibility versus cohesion. These are trade offs that real engineers actually have been making for decades. So if you continue to invest in understanding those aspects of software engineering, you will always have an opportunity and always have a job, right? But if you don't, that's where the problem will occur. AI is good at understanding the pattern between some input and some output. And over the last few years, AI has increasingly been able to increase, I'll say AI has been able to, but AI platform providers have been increasingly adding to the context window available for models. So now, before the context window was about a page worth of information, now you can add a book worth of information. And yes, that makes it easier for AI to think systematically, but AI still cannot include and reason about the level of systems that humans are natively and innately able to reason about reliably. With your guidance, AI can help understand a specific component inside of a system, but you are still required to understand at a high level how do these different systems interact, what are the things that are important, not just from a architectural standpoint but from a societal standpoint. What does the customer really care about? What are the regulations that matter for a product like this in regard to this specific component that I am looking at today? That's something that AI cannot easily do yet, and that makes your job as a troubleshooter for AI generated tools and for automated systems much more impactful, because you can see the connections between different components that AI is not yet able to understand on its own. That's something very useful. That's something that you can keep as a skill today and in the future. Again, security. Security is still not something that we can trust automated systems with yet. Yes, we do have automated monitoring of certain systems, and that can be done with AI, or really just traditional automation to monitor and alert on different uh, patterns as they come about. But someone still needs to be accountable for the system and its security. Someone needs to be accountable for making sure that the numbers from a financial perspective that we are saying are here is actually the same for the, same from a regulatory standpoint. Like, you can't just trust AI to do everything without fact checking it. And so those skills are going to be important. Even if you're not day to day handling the operations, being someone on the ground who can actually go back and double check the work that AI has been doing to say, all right, this is the output that it's been giving for these types of input. If I go through it manually from a show your work, check your work perspective, am I getting the same result? If I'm getting the same result, all right, we can keep the system in place. If not, we have to shut it down. That is something that a human is still accountable for, even if we're not the ones doing it day to day. And again, we're not fast enough to do it day to day. The AI systems are probably going to be better from a efficiency perspective, especially from a high load capacity. They can do more in less time than we can, but we still have to be on scene and understand the system from a high level perspective to understand when things are going wrong and when things are going right. But the major skill that every engineer needs to have as we go into the future is the ability to learn. Great engineers for decades have mastered their ability to pick up new skills over time, pick up and understand new technologies over time. And these are the ones that are going to have an opportunity no matter how the technologies and tools change around them. That is going to be your edge as AI gets better, as people continue to enter the space and engineering gets more competitive. Your ability to learn quickly and adapt to the current situation and not just say, I know how to do something that we've been doing for 5 years. Because 5 years, things can change. 5 years, things should change. So being able to pivot quickly is going to be incredibly important, especially as we start to operate at different levels of abstraction in business and in technology. So that's pretty much all we had for this week. Um, Again, thank you for leaving these questions. And if you have any more questions on how you can improve as an engineer, uh, put them in the comments, message us on Instagram, and just let us know how we can help you become the better developer and better engineer. Because again, we need builders that understand these different nuances inside of these systems that we are using every day. So let's continue to grow in that way. Something that I was thinking from a mindset perspective for this week is that with all the things that are happening in the market, inside of in labor markets and the economy, figure out how to block out the noise. I'm not going to say today exactly how you can do it, and I'm not even going to define what noise is for you today. But understand that there's a lot of noise happening and being put out all around us. Understand what you care about, understand what you want to focus on, and focus on that. Block out everything that is unrelated to the objectives and the goals that you have for you and your mission. Make sure that once you have a clear idea about what is important, that everything else that is not inside of that, that realm gets filtered appropriately. And filtered may not mean you disregard it completely forever, but maybe it means you only focus on it or you only give it a very minimal amount of attention on specific days. Day to day, you are going to hear things that may or may not true, may or may not be true. You are going to hear things that may or may not be important to your health and your well-being. And it's going to be incredibly difficult to actually discern those differences as AI gets better and more realistic. But you have to continue to understand the difference. You have to continue to be mindful about what's important for you and what's not important for you, because no one's going to make that distinction for you. And if they do make the distinction for you, they're probably going to emphasize or over index on something that you really should not be caring about. So, whether it is engaging with your family more, improving your skills as an investor or as an engineer or as whatever you want to be when you grow up, make sure you have that clarity and make sure that you have systems in place to filter upon the information, that input that you're getting. Uh, Set up your own, rules for when you should be even given something that's outside of your focus any attention, because everything don't deserve all of your time. Just keep that in mind. Figure out how to block the noise, and if you need some time away from everything to even decide what is noise and what is not, take that time for yourself. Take some time to make sure you have a space and an internal state that is available to even decide what's important for you. That's really my message for this week. I hope this has been helpful. And continue to build, continue to learn, and continue to have impact in your community. I'm checking out. Have a great week. Happy Sunday.